Yeah, it doesn't let me. How did you get to the? Okay.
You need a premium account to do that. It doesn't work with a free account. That's what we do for Polaris.
I see.
Okay, my recorder is in and going, so we do have a recording. I can send it or put it on. I'll just put it on the YouTube channel. That's probably the best thing, right?
Yeah, cool. I'll admit. Give it another few minutes. Oh, okay. I just got it. Okay. Just made it open. Okay. Okay, cool. I think it's 5 minutes past. I think we can get started. Thanks everyone for joining. Essentially, one of the what kind of the goals of this is to talk through essentially what a few of us in the community have been thinking about for a new sort of V4 content metadata tree structure. So this is the kind of result of sort of two groups of people kind of thinking along the same lines on how to address a problem and working together. We want to talk through our ideas in the community. Let me share my screen. Okay. Right. So yeah, as I said, I think a few of us in the community have been thinking about like how do we kind of evolve the content metadata tree structure in Iceberg to effectively support efficient single file, more efficient single file commits. Thanks, Anoop, for pinging the doc in the chat. So yeah, this was sent in the mailing list a while back, but yeah, effectively today, if we look at the structure of the tree today, a writer producing a single data file has to not only write that data file, but they have to produce a manifest file, a manifest list, a metadata JSON, and then commit that, and produce a metadata JSON. If it's an IRC, the server is writing that, but if it's not, a client produces that and commits that. For a series of like small writes, this is arguably higher metadata write amplification and latency than that's actually necessary. And so effectively, what we were kind of thinking through is, can we do better here? Furthermore, effectively, removing a file in a manifest today requires rewriting that manifest in a copy on write fashion. So sort of to alleviate these issues and some additional kind of structural gaps in the tree, we're proposing this kind of new metadata structure for V4. Before I get too deep, I actually kind of wanted to talk about how I'm thinking about like going through this. So this is a very long doc. I'm not planning on like reading like everything in detail. I think the way I'm kind of envisioning this is essentially that we first, oh, is it still? Okay. I made it open. I'm not sure why it's. So effectively, so yeah, so the kind of agenda. So I think I first want to give a crux of like how we're thinking about addressing this. Just go over the high level ideas. Folks, feel free to jump in if you have any questions or concerns. There's a set of open questions from like people who've been working around this doc. But before we get to those open questions, I think it's better that like folks that have questions around the core of the idea, the goals. I think we can talk through that first. I think. Are there any objections to that kind of agenda, I guess. Okay, cool. So yeah, at the core of this, like I said, we do want to reduce metadata write amplification for smaller writes. So there are certain operations which are writing a new metadata file on the client. Essentially, and like I said, we could also reduce metadata write amplification for removals and replacement for manifest entries. Another aspect we're looking at improving is, the ability to generate metadata proportional to the size of the operation. So today, as an example, when we remove a set of files from a manifest, we have to rewrite those set of manifests, and that's essentially producing more manifests or it's higher metadata write amplification than really necessary. And we can also improve cacheability if we were to essentially not rewrite manifests as aggressively, since those manifests could be retained in a cache for longer periods of time. Another structural aspect that's being looked at is today in the manifest list structure, there are only essentially partition field summaries. However, there's no other columnar statistics information at the manifest list level. So one of the structural improvements we're looking at is can we have essentially a top level manifest that has aggregate metrics for all the leaf manifests. And the kind of other big goal is, are we able to essentially just do change detection, like file change detection, file additions, removals, or replacements, just by looking at the root of the root level in the tree. So we should be able to ideally detect changes just by looking at the root in the metadata tree. Something that I think is considered out of scope for this is essentially the removal of the removal of metadata JSON. This is something that's been discussed in the community. There's other somewhat related discussions around, server-side commits through IRC, but effectively that is something that is not really considered part of the content metadata tree, at least as far as this proposal goes. Any questions here while I admit people? Okay. Yeah, so the crux of the proposal is essentially this. Effectively, there will be, every snapshot will essentially refer to a root manifest. So in today's world, this is essentially the quote manifest list, but in the new proposed model, this is still just a manifest. But I'll get into what contents can this actually store in a little bit. But it's effectively a manifest, and root manifests can contain the following types. They can contain data manifests, they can contain delete manifests, they can contain data files, they can contain DVs, they can contain equality deletes, and they can contain manifest delete vectors. And I'll get into what a manifest DV is, but effectively a root manifest can not only contain pointers to other manifests, but they can also contain these kind of, the data files and DVs, the leaf level of the metadata tree that exists today. So this is kind of the core enablement of these single file commits. Basically, smaller writes can be targeted and be written in just the root manifest directly. So that's what the root manifest can contain. There's exactly one root manifest in the tree, and essentially, so I'll get into manifest DVs now. So effectively, what a manifest DV is a DV that indicates which positions in a leaf manifest are deleted. So as I mentioned before, one of the challenges today is when a file is removed or replaced in a manifest, we have to rewrite that manifest. But with a manifest DV that exists in the root, we can indicate directly that that position in the file is in the manifest is deleted without actually even touching the manifest. So that's the core of the idea. These manifest DVs are only allowed at the root level. And one of the open questions is like, should they only be inline? Can they be can they be external if they get too large? I think we have some data points to show that largely we should be okay with just allowing inline manifest DVs, considering the scale that they'll generally kind of operate at. Yeah, I'll pause here for any questions because that's a lot. Okay. Yeah, so one of the core ideas is also we want to be able to leverage stats as much as possible at almost every level in the tree. So today, we only have partition field summaries at the root. We're looking at, can we have just use column stats at the root as well? So the manifest level, at the root manifest level, these stats would be aggregated stats. So because the manifest refers to many, like potentially many like leaf manifests. And so those will be aggregated. Yeah, I think I'll get into change detection a little bit later, but that's another idea. Another kind of, maybe this is because something that needs discussion, but I think largely we're pretty set on is the true depth in this structure is 2. And the reason we propose to limit 2 is that in this, if we were to not limit it, writers could produce very skewed trees because it basically allows for faster writes, but then the read parallelism is severely limited because you have to read the manifests in a hierarchical order. So imagine like a very skewed, like basically linked list of manifests that have to be traversed. So, but that's, and I think sort of from our analysis, we're really confident that this can scale. You still scale really well as long as we have larger leaf manifests. Oh, okay. Peter, you have a question?
Yeah, thank you. I started to raise my hands when we were talking about stats and aggregated stats, and I was wondering how it would work with the manifest delete vectors, how the aggregation could work in this case. So we can have aggregate stuff in for the manifest list, but when you are removing specific manifest, then you need to recalculate those stuff somewhere.
So I guess this means like the stats are not tight. That's what practically means, right? So for example, if you have upper or lower bound, we may not have data, that has that value, right?
Yes, yeah, exactly. You don't have to recalculate stats, just like we don't recalculate stats when you delete from data files today. So the stats, like Anoop was saying, they represent lower and upper bounds, and the counts represent what was in the file before deletes.
Okay, thanks.
Yeah, right. The entry stats don't need to be updated. Is like, I guess, the point. Yeah, but they are not exact. Yeah.
Yeah. So if there's a DV against a data file and no equality deletes, you do know how many records are in that file, but your nan count and null count may be higher.
Yeah. Okay.
So that practically means like, by definition, stats are not tight. So you could not answer a pure aggregation purely based on stats, right? And that's what the implication is.
That is true. I think, okay, I guess we'll get into this a little bit later, but I think I think we might need to consider introducing the notion of exact bounds. But I think that's a separate thing, I guess. But yes.
What Delta Lake has, right?
Yeah.
That's there's a Boolean that indicates whether the bounds are tight or not.
Yeah, didn't Parquet add this as a footer property lately? So you can actually specify in the Parquet footer as well whether the bound is exact.
It did. There's also a proposal to add it to Iceberg, but I don't think the person that proposed it had the fortitude to push it through.
Okay. Yeah, Anoop, you might see we actually have some aggregation pushdown in the library right now, and it all just is like, and if you see any delete vectors or position deletes, give up immediately.
Yeah. Okay. I'm not sure if I see all the hands, so I want to make sure I'm not. Okay. Cool. Any other questions so far? I think I just covered the tree limit, tree level like depth. Any questions, concerns around that? Okay, I will proceed. I think there's like a lot of details around like how different commit operations can be expressed in this tree. I don't know if we want to go through every single example, but essentially, you know, for appends, you know, for small writes, they can be targeted to the root. Even for a larger write, if it produces data manifest, writers would produce that manifest, and then they would write a new root manifest that refers to that data manifest. So that's kind of the general idea here. Removals can be expressed in technically two different ways. So you could, you know, if it's just at the root, well, technically three different ways. If it's just at the root, essentially you could just like mark the file that's being removed as deleted, and that just still exists in the roots. Actually, I want to because I think I said something that there's a structural change here as well. So currently in today's manifest structure, in today's manifest structure, writers are not required to, if a file is deleted and carried over, writers are not required to essentially materialize that status, you know, in a new manifest. So that kind of makes change detection a little bit difficult. And so one of the things I think we're considering is that these statuses must be explicitly written to make that change detection easier. So that's why in this case, in this model, we would ensure that an entry with a deleted status is produced. Any questions around that? Because I think that's also been a pain point in the format. So yeah. Okay. Let's see. Yeah, another way to express a delete, like we said, is like you could just produce a manifest DV, and a manifest DV just indicates which position in the file is removed. Yeah, Talat?
I was going to ask for previous, you know, the diagram. If you scroll up, I didn't understand the one thing. Just go a little bit up. Yeah, here. This snapshot is on the metadata file. Then the root manifest is kind of manifest list, and this is a data manifest. Rather than we generating multiple data manifests, just one data manifest is pointing the root manifest, right? This is the only change, and it still looks like old style. The only difference is that rather than having one manifest per file, we will have just one data manifest for multiple files.
So this example is basically showing the old style. So like you can do the exact same thing you're currently doing, where you basically treat the root manifest as a manifest list. And if you want to add a whole bunch of files, you add a new data manifest with a whole bunch of files in it, and you add that to the root manifest. So that's what this last example was. So if you go through, we basically have the new ways, and then I show like this is the old style. So there's nothing, if you really like this, if this really worked well for your ingest patterns, you can still do that.
I see. Okay.
Yeah, right. So I think to Russell's point, like, you know, we're talking about improving the format for single file commits, but even for these like very large style, like large commits, as you said, the structure of the tree still enables like being able to just do effectively the same writes. So yeah. Cool. Any other questions? Oh. Okay. Yeah, manifest DVs. I'm not sure if we want to go through every single combination here. There's a lot of detail here. I think that the original proposals, so like Russell and Stephen and Yifan, those folks have put together. Okay. Are there any other like broad questions? Because I don't want to skip too far. Okay.
Is each manifest tied to a single partition spec?
I think not. I don't think that should. I think we should. I think I left that as an open question, but I think I don't think so, because effectively we want to enable, I think, flexible like kind of writing patterns that essentially don't force a single manifest to like only have entries that are tied to a single spec, right? You can have entries that are spanned across different specs. Like just, I think it gives that flexibility. Yeah. Okay, I think this is also marked as an open question, but another thing that we were thinking about is kind of an optional affinity between data manifests and delete manifests. So what affinity is essentially that like every well, okay, I won't describe affinity yet. I'll describe what the current state of things is. So today we have separate data manifests and delete manifests. And to reconcile which delete files to apply for which delete file to apply for a given data file, that requires a two-phase planning because of there's effectively this complete separation, and we won't know without reading the set of delete manifests for a given partition like which files need to be applied. So this is what we kind of refer to as two-phase planning in the project. And so this provides this flexible writing pattern where like delete manifests can just be like produced, right? Without having to like think about like any association. Sorry, go ahead. Oh, okay. I thought I heard it. Okay, so what affinity is effectively in this model, every single, or not every single, but like a delete manifest can refer to a data manifest. And what this indicates is that all the files in that delete manifest are associated with data files in the referenced data manifest. And so what this enables is effectively a co-located two-phase planning, where essentially we don't have to do a more expensive reconciliation of which delete files to apply for a data file. We know exactly based on stats, like which data manifests we need to read, and as a result, we would know which specific delete manifests we would need to read. Now, the key here is we're proposing an optional affinity. So technically, writers still have the flexibility to produce unaffiliated delete manifests. And so if those are produced, those also at read time have to be reconciled. But I think the general idea is that set of unaffiliated delete manifests would be small. And so the primary benefit is, yeah, we do get a much more improved it's still arguably can be two-phase, but it doesn't have to be, I guess. They get a more effective single pass planning, and then you can actually use stats to prune like which delete manifests to read. And this still preserves like low write amplification. So when we're replacing the DVs, we know which delete manifests have to be kind of read and rewritten. Any questions here? Yeah, go ahead.
Sorry, I didn't know if we wrote this down yet, but I'm also interested. Did we say? Yeah, okay. So we have it up at the top that this is a one-to-many possibly relationship. So like the assumption is we would do like a sort merge kind of resolution of delete vectors to data files, where we open all the delete manifest with affinity and walk through them at the same time as we walk through the data manifests.
Yeah, so that's an option. There is, I think, another option, which is maybe if we have a sort order in the root manifest to put the delete manifest first, but there's a trade-off there. Are we sure about enforcing sort on the writers enforcing that sort? So yeah.
I think that the root manifest is going to be small enough we can fit the entire thing in memory. So we don't necessarily need to sort or require a sort order for it. For the rest, right, you basically need to read through the manifest, then go find any delete files for the files that you've projected. And so you have a very tight filter when going through the delete manifests that have affinity. And as you're going, you're also probably applying a delete index that has all of the unaffiliated files or DB references.
Yeah, I was just kind of thinking about like if we had an ordering within the delete manifests, we wouldn't have to build up like the index structure the way we normally do. But I don't know, I gotta think about that some more. I think this is a good idea though. We should definitely implement it.
Okay. Ryan, I saw you thinking. I wasn't sure if you wanted to say something.
I'm not sure how we would get rid of the delete index because you need to at some point either like scan through all of your deletes that could apply to any data file and index them, or scan through your data files and then look for those data files. I think that we would probably use the same index and then scan through data files approach that we do today, because we expect the holding that set of deletes in memory to be much smaller than data files. And then as you go, you know that you can release data files as you find them. So I see a data file, then I check the index. If not, I just release it as a task. So I think that we would probably use the same approaches today, but it's not something we need to really cover.
Yeah, sorry. I'm thinking of potential optimizations because you would be able, looking at the root manifest, to immediately determine if there's no unaffiliated delete manifests. So you could potentially go down a different path if you know a little bit more information, like if you can guarantee an ordering in delete files by like file name or something, because then you can just be like, oh, I don't have a match for this one, continue. More complicated, but maybe, I don't know. We forget about it for now. This is an implementation question for a long time from now.
Sounds good. Yeah, I think I'll present the kind of one of the alternatives, right? And kind of show like maybe just briefly demonstrate why I think we discarded it. So another approach is like you do co-locate. We don't actually have the separation between data and delete manifests, and then you essentially co-locate the delete with the data. But the challenge here is anytime if you sort of are mostly churning through DVs, mostly churning through like these delete cases, there's really high write amplification because you have to rewrite the data file entry as well, and that has a lot of stats, and that it's much bigger. It tends to be much bigger. So yeah. Damn, I meant it's open, but it's like not. Yeah. Okay.
I think that it made the next instances open because you did the calendar invite and not the current meet.
Okay.
Hopefully you don't have it next time.
Yeah. Sounds good. Manifest structure. I think this gets into a little bit of the weeds of the manifest structure. That's important. If anyone like has concerns, like please comment on the doc. But I think it's probably more helpful to maybe for us to talk through any of the open questions, because that'll help drive like how we actually want to structure the manifest, I think, like the entries in the manifests. So I'll skip ahead to open questions. Unless, is there anything else that people want to bring up? Okay, that's the one I wanted to talk about. But I don't know if anyone else. Okay, good. So I won't necessarily go in order of these open questions. I think I'll start with the question Russell prompted, which is, should we essentially remove the partition tuple? I fall in the camp of yes, because in the current, in a world where you have like column stats at essentially every level, and most partition transforms are monotonic, with the exception of bucketing. Effectively, we can prune. I think we can prune just as good, just based on stats. There are a lot of nuances here. For example, like I think Micah brought up like a while back, like if you have for example, a string, right? That can be truncated, right? And how do we make sure in stats that it's not? Because that makes a huge difference for like, basically queries or just need the partition information, right? The exact partition information. So those are nuances, but I think I look at this as two ways. It's like, should we keep the partition tuple, and then can we? Like, how can we? I think the should we is the argument for not keeping it is that in the presence of column stats, it is effectively duplicative for what I think we kind of need to achieve. There is a trade-off that the transforms need to probably be applied at read time, at planning time. But what are we getting by keeping a materialized grouping of values that we can already kind of derive?
So, Ryan actually raised his hand. I was just going to start talking. So this is like, I think an issue like, can we do the non-range preserving transforms like bucketing in this model? Like, we might have to give up on that. I don't know if that's like something we really need to keep, but I assume we need the actual tuples if we want to do a non-range preserving transform.
We do. We need the values.
We need the values. Yeah, sorry, go ahead.
Yeah.
So yeah, what you still need to do is, because we still need to compare actual partitions in order to apply equality deletes, which are scoped to a partition, we still need to be able to construct the partition tuple. So then it is, basically, how do I store the value for a file that happens to be partitioned by something? So this is where we've talked about having a derived value in one of the stats structs. So if you have a stats struct for a category column, you would have, and you're also partitioned by that category column using an identity transform, the struct for it would have a derived value with a untruncated string for that file. And then you could have lower bound and upper bound as well for manifests. And you can apply the same idea to a bucket transform. So you would have a stats bundle for, bucket of ID, a derived value for a single data file, if there is a single derived value, or a range of values, lower and upper bound, if you have, multiple values within the file. So we can essentially, using this derived value field, if there is one and only one value for a given expression or transform, we can basically store the exact same data. Then the question is, do we want to store the exact same data in the stats structs, or do we want to just have a partition tuple? I'm actually kind of leaning towards having a partition tuple, because I think that's easier to reason about and is a smaller change, but I think that they're essentially the same thing. And what we would also need to do if we have a partition tuple is make it so that it is the union of all partition fields across all, it's sort of that, the structure that we project for our metadata tables today. So it's a little different anyway. It would be, this is an area it's open, but we know that we need to be able to reconstruct the exact partition tuple that we have today.
That's right. Yeah.
Baka?
Yeah, I was too early. That's actually exactly what I want to say. Like if you have multiple partition specs in one manifest, then we need to have you just have an arbitrary tuple, right? But I think we can do that if you just assign like the field IDs correctly. But this tuple will change all the time probably, which I think is okay. It's an interesting thing.
Yeah, it has to be a union, right? So I think like of all the historical spec, or not the historical specs, but the specs in that manifest.
Yeah, union of all the fields in all partition specs of the table, which actually is not bad, but it's a slightly different way of storing these things. I think it would actually be preferable to store it that way. We could extend the existing manifest structure to do this and be able to mix partitions together, and that would be a positive thing overall. Micah?
I'm still not clear. Like, so in the world where we're like going to changing how we're indexing stats and we're like changing to this 2-level tree, could you maybe repeat? I'm not sure I understood like the benefit we get from keeping the tuple.
It basically does not change the existing expectations or structure. We need to be able to reconstruct the tuple in order to compare them, but
compare them for what?
Equality
deletes.
Yeah.
So an equality delete is scoped to a certain point in time using the sequence number and a partition of the table. So we need to be able to check, is this equality delete in the same partition as this data file, right? And so we will be able to construct these no matter what. The question is, do we want to store the data in the new stat structure and completely get rid of the old, or do we want to combine these values and keep them in a partition tuple struct?
Do we need like to have all the like a union of all the specs in the table? You could also just take a union of the active specs.
Well, yeah, effectively.
Yeah.
A union of all the specs used in the file, or sorry, in the manifest, except that when you're creating the manifest's schema, you don't know all of the specs that are going to be fed into it. So you will effectively use all of the specs in the table because you might have one that is the set of things that could possibly be used.
Yeah, that's a good point.
Mm-hmm.
So if we got rid of equality deletes, would that change our decision here?
Yes, if we got rid of equality deletes, we would definitely get rid of the partition tuple.
So Ryan, I guess I think the question I have though is like, we know we can probably reconstruct the tuple just from the stats. Like the bucketing case is like, as you said, like that's a derived column. Like what is the benefit of storing the materialized tuple versus deriving it on the fly?
Well, so I think of it this way. If you have 3 partition fields, you can either have a struct with 3 fields, or you can have 3 structs, each with a derived value field. I think that it is a smaller change from what we do today to just continue storing a partition tuple. If we were to say, okay, we're going to take this partition tuple, replace each field with a derived value field in a stats struct for each of the fields. And by the way, I need a stats struct for, basically all partition fields. So I might create stats structs where I would not otherwise have them and things like that. It's just, more kind of confusing work.
Okay. Yeah. There is definitely a implementation cost to this for sure. Yeah.
And I don't feel strongly one way or another. I've actually gone back and forth on this. I'm currently leaning toward, rather than having a derived value in a stat struct, probably don't. But there is a good argument for doing that, especially because we think that partitioning is going to be less and less of a thing as we move more towards clustering instead. And we also are, hopefully finding ways around using equality deletes, because we haven't really seen much success effectively using equality deletes.
Yeah, yeah. Oh, okay. I think that makes sense. Is like arguably we could use, if there's ever progression like trying to eliminate equality deletes, like that would be a good justification for removing the tuple, because at that point it's not needed. Yeah.
When you mention derived value, do we really need to use one per field when we just need one for the transform that the spec for that file is associated with? So like a generated expression rather than one per field, because we basically could just then store one derived value, which is a struct.
True, yeah. So if we have an identity field, we would probably just stick the value in the column itself, the column's stats struct itself. If you have something like bucket, then you need to make sure that you have a stats struct for the bucket function. Yep.
This is something I was just thinking about too, which was like to detect if a file, if we were to just use stats, to detect if a file is partitioned. I think Ryan, we were talking a while back, like you could say that the lower bound of the transforms of that file, of that column, is equal to the upper bounds. But this is under the presumption that the stats are exact. And
it's best to keep lower bounds, upper bounds, and derived values separate. That way you don't have any truncation issues. That way I'm uncomfortable with the idea of guessing in those areas.
Sure. Okay. Yeah, I was just making the point that like in this model, I think we would have to solve the the exact bounds, but I think that like it's good that, and I guess in the other model you don't necessarily have to solve it. So, sorry, Paula, go ahead.
I just want to ask, to improve my understanding, what is the problem with the equity deletes? My understanding is that equity deletes is very useful for inserts, but Ryan, you say that
cheap rights, but they're very expensive to apply. Yeah.
So equality deletes can't be combined across. So first of all, they're not very narrowly targeted because you don't know where the file was. So the only thing that you can do is determine the partition that you're applying it to. So if you have 100 files in a partition, a single equality delete file applies to all 100 files. You also cannot coalesce them over time because they need to apply to specific sequence numbers. So if you delete, append, delete, append, delete, append, you have one equality delete for every time you deleted that applies to all of the files that were there at that time. So it's really expensive, and there's a lot of amplification on the read path for doing this. That's okay as long as you are pretty aggressive about doing the work to say, I know where this equality delete gets applied because I'm going to actually go scan those files and turn it into a position delete or something like that. It's fine as long as you have very few equality deletes in the table. The problem is the implementations that produce equality deletes have historically not done any maintenance and not actually cleaned them up. So what we saw in practice was anyone actually using this would have thousands of equality deletes in their tables and would basically have really, really slow scans because they're not doing the maintenance work required. So this was, we can implement maintenance or we can look into other structures that allow us to have cheaper writes. So you might have an index structure that you can look up entries in to be able to create position deletes instead of equality deletes in almost the same amount of time. Like we want to look into alternatives because equality deletes just have not been effective so far. But we haven't deprecated them, so we need to make sure that we can still at least maintain what we do today with equality deletes.
For V4, do you think that should we work on the spec change for the to solve this issue also?
So the biggest question with equality deletes is if we are going to replace them, what are we replacing them with?
I see. Yeah, we don't know yet.
We don't know yet, and that really would delay things to figure it out. So I think it's reasonable and wise to maintain the support that we have today, and discourage their use. There are some companies that do use equality deletes and are maintaining them across versions and rewriting files and like keeping track of things. So we don't really want to just dump the feature, but we do want to figure out how to make it more effective for people to use.
Okay, thank you. I got it. And this also answers the partition tuple things, right? If we have the equal to deletes, then we cannot drop the partition tuple at all.
I think that there's also an open question. We also know that partition filtering in today's manifests is significantly faster than stats filtering. That's because we actually have to parse each lower and upper bound value. It's actually like kind of an ugly process. So it would not be unreasonable to say like, hey, maybe partition filtering is still a good first pass if you have partitioned values. I'm not convinced by that argument, but that's something that we can at least benchmark and test.
I agree. I was also thinking about that, but I think measuring that's probably the best way to prove it.
Yeah, Micah?
I think you can also solve that particular thing by having a notion of exact value rather than min and max.
Well, I don't think that actually matters here, because lower and upper bound allows us to do actually better comparisons, because you can replace a min or max value with an actual like shorter bound value. The main thing here is just the number of comparisons and the work to parse and stuff like that. So if we're talking about using a columnar format, it could well be that a columnar format gives us just much better performance out of the box, because we don't need to transform the values or interpret binary.
Right. Yeah.
I mean, yeah, you're still interpreting binary, just it's happening in the file form, like in the file format. But yeah, like either way, it's fine.
Okay. Are there any other questions? Otherwise, I'll just move on to one of the other open questions. Okay. So I guess I'll start from the top. So manifest like DVs, one of the open questions was like inline, puffin, or both. We've done some like kind of measuring and benchmarking around like how many bytes per delete we expect, and roaring bitmaps take around 2, and there's some like data points. I think I wouldn't make anything conclusive off of this yet, but like I think there's some data points to indicate that like if you have multiple runs of these DVs laid out in a columnar fashion, that they do compress okay, like it's better. So I think my sort of analysis is kind of like we should be okay with just inline DVs, and like any case in which we would write an external manifest DV is a case where we'd be better off just rewriting that manifest anyways. So like that's my take, but I wonder what other people are thinking. Yeah.
I think this comes down to numbers, but even with the 2 bytes per value, I don't see a compelling case for external DVs. I think that we will probably have enough churn in manifests that we rewrite them fairly regularly, right? This is to defer work, not to put it off indefinitely. And so like I think that we will be fine with inline DVs. And that also means that we are the format is basically simpler, and you can encode all of your changes in a single file write, rather than needing to write a whole bunch of DVs to a Puffin file. And on the read path, go find all the DVs and open a bunch of different Puffin files. So I think that inline is probably the way to go. And if you hit size constraints with inline DVs, then the answer is almost certainly go rewrite some files, because you can drop the size of the DVs in the root by rewriting manifests, and that is almost certainly better than just scattering DV content across additional files.
Right. Okay. I think we talked about manifest affinity a bit, so I'll go to the other one, which is change detection. Oh, go ahead, Talat.
I just want to ask again for my clarity. How many requests we are going to do for the small write or read cases? Currently, per data file, manifest list, metadata, and if there's a DV, also DVD manifest. Is this reduced significantly, or it is still high?
I didn't quite follow the question.
Yeah, same.
As a client, I need to call the metadata, then get the manifests for scanning, and they get those information. Then it will increase. If I have so many files to scan, then it will increase my request count to blob storage.
Yes.
With having the inline DV, will it reduce that or not?
Yes. Yeah. So the inline DV is saying we're going to put the DV content inside of the root manifest file itself, rather than storing it in a external DV like we do for data files inside a Puffin file. So rather than when you read the root manifest, you'll get manifests and deletes against those manifests without having to go read another file to get the deletes against the manifests.
I see.
Also, the inline here most talk about the manifest DV. Yeah, for data DV, they can be in Puffin file, because the engines, when they produce a data DV, they can already read the Puffin file.
Exactly, yeah. So the data DVs are always in Puffin files. We don't allow inline data DVs today. That is because those writes are parallelized, with the write operation that's taking place. So you write all of those in parallel, and then we collect them and commit them to the table, just like you would for data files. So the actual data DVs are considered content. The inline DVs that we're talking about here are just against manifests and the content tree itself. So this is intended to allow you to very quickly, delete a data file or a DV entry without actually going and rewriting that metadata.
Okay, thank you. You answered my question.
If you look at the top, we have some diagrams that show where this happens. Like one of the key things I think we keep alluding to is if you have cached your manifest information, you only have to read one new file if none of those manifests have changed, which is the root manifest, which has the information you already need to know what to invalidate in your already loaded manifests.
Yeah, I think that's a great point. I didn't really go too much in depth here. I just kind of mentioned in the goals, but like, yeah, one of the side of I guess properties of this structure is there's like improved cacheability, right? Because like if you are essentially like having a delete manifest or even a data manifest in cache, right? Essentially, the fact that you can encode manifest DVs enables that data manifest to reside in cache for longer, and it's inline, right? So the root manifest also is like, so yeah, because the root manifest will, I think, tend to be pretty small. It can also fit in memory. So, yeah. Okay, I don't know how much time we have left. Oh, okay, it is like 1 minute left. I think it's like not too much time to talk about change detection. I think that's an area, one of the properties I think we're trying to go for is like being able to effectively detect changes at the root. I think one of the ways to do that is essentially you could like have a diff DV, which encodes changes, but that's, I think we can table that for the next discussion because I think that's a pretty involved conversation. I think we want to sketch out more change cases. So I think that's something we can probably talk through next time. So I will follow up on the mailing list, like with a summary. If people have concerns, please reach out. Please send stuff on the mailing list. I'll try to get to it. Anything? Otherwise, I think we'll call it.
Thanks, everyone.
Thank you.
Thanks. Bye.
Bye-bye.